All right, so this starts off just with a reminder of what we talked about yesterday about what a rational function is. And then just a reminder that we did previously solve polynomial inequalities, and so now we're going to use those same concepts with rational inequalities. All right, and so I'm letting this f of x be basically the numerator over the denominator functions. And f of x is going to be 0 when which one of those equals 0? If you were just guessing, would it be where the numerator equals 0 is going to make the function equal to 0, or the denominator? The numerator. Because when the denominator equals 0, the function is going to be undefined. Because you can't divide by 0. Dividing something into 0 equal parts doesn't even make sense. So that's why the function will be undefined whenever the denominator is 0. Okay, so in this first example, that's what we're going to find. We're going to find where the function is undefined, and we're going to find the zeros. So the function is undefined. We're looking at the denominator. What values of x are going to make that denominator 0?
-3.
Very good. Okay, and then when we're doing the zeros, we're going to look at the numerator. Trying to figure out what makes those factors 0. So that's going to be -1 and 2. Not too bad. All right, for B, it has a little bit of a catch to it. So this is why I wanted you to define undefined first. So where is this function going to be undefined?
-6.
And one more? 3. Okay, so do you think a function can have a 0 where it is undefined? Absolutely not. So where a function is undefined, it doesn't exist on the graph, so there cannot be a 0 there. So what do you think that there's only one 0 here, and where is it going to be? At -3. So we're going to write that. So a function cannot have a 0 where it is undefined. In the next lesson we do, we're not going to actually do it until Monday. We'll start talking about what happens there when they have this common factor. All right. In this last one, we're going to need a factor first before we can find the zeros and where it's undefined. All right, so you guys figure this one out on your own, where the function's undefined and where the zeros are. All right, so what can x not equal?
6.
Good. What about zeros? There's not any. Good. It doesn't have to be a 0. There doesn't have to be a number that makes the function equal to 0. So there's nothing that you can plug in to make this 0. And that's fine. All right. So here's the big part of today's lesson. Well, you do have to understand what we just did to do the next thing. Does anyone have a question on how you find where the function is undefined or the 0? Okay, so whenever we're solving these rational inequalities, you're going to, just like before, we're going to do that number line. And on the number line, you have to put in all of these things, where the function is undefined and where the function is 0. And then we're going to do the whole testing the points things, all that all over again. Now, there is a typo here because I changed Brian Passwater's notes just a little bit. I like to call the top function numerator, or n of d, and the n of x, and the bottom d of x. I just forgot to change it on that one little part. Okay, so I'm just going to kind of talk about the steps as we do them. These are really good directions for the steps. This step 6 should be in test values in each interval to see where the intervals are positive or negative. But everything else is filled in. So if you forget, you can always go back and look at these. Okay, so I'm just going to start off with drawing the number line. And then how many values am I going to need to label on here? 3. So 1 for each number where the function is undefined, which is going to come from the denominator, and then 1 from the numerator. So -6, 2, and 3. Now the extra thing that you have to worry about with rational functions is the open and closed circles. So before it was pretty straightforward that if it had the or equal to 2, you did closed. If it didn't, you did open. This is not the same. So these values that you get from the denominator, the -6 and the 3, they have to be open circles. Because you cannot include them. If you include them, it gives you 0 in the denominator. So if it's something where it's undefined, automatic open circles, no matter what. And then from the numerator, then you have to look at this guy. If there is an or equal to bar, then it's going to be closed. So that's just an extra thing you have to think about on every problem. All right, and now what we're going to do is pick a x value to test in each region. Now I will always do 0 if it's not a value on your number line, but you don't have to. Someone in my other class just really wanted to do 1 and said 0. It doesn't matter as long as it's in that interval. All right. And so we'll just set up our parentheses. It's going to look a little different because we have a fraction. So there's 1 set in the numerator and 2 in the denominator here. All right, so the rules for multiplying and dividing, negatives are the exact same rules. So an even number of negatives is going to make a positive. An odd number of negatives is going to make a negative, just like when we did this before. So I'm going to plug -7 into each factor and just determine if I get a positive or a negative. And then just like I said, an odd number of negatives is a negative. Same thing with 0 and 2.5 and 4. What do I want for my answer regions? Do I want positive or negative? So because this is greater than 0, I'm looking for the positive, so it's this section and this section. All right, and then somewhere where you guys have room, you're going to write the answer in interval notation. So pay attention to your brackets and your parentheses, because it can change up a lot on these. So if it has the closed circle, we do the bracket. If we have the open circle, we do the parentheses.
Wouldn't that be 3?
It would, thank you. I was trying to figure out why your faces look like that. Okay, now I'm not going to do all these examples unless you really just want me to. But we are going to do example 2. Example 2 is a little more challenging because you have to factor. And then to make this a little easier on us, I'm going to change that denominator to x minus 5 quantity squared. Because I know on that one, there's one less set of parentheses to do, and I know it's always going to be a positive. It'll just save us a little bit of time. Okay, so I have my number line again. Going to have 3 marks on it. Okay, and I automatically know if we're coming out of the denominator, it's open circles. What about the numerator this time? Also open, good. Oh, and then I go and do close. Same old. Plugging in some numbers. This one's actually going to be a little bit quicker now from this point on because I know for sure that denominator is positive. And then this time, because it's less than 0, we're looking for negative. So it's just going to be one interval. I'm going to squeeze it up here. -2 to 2. All right. So I want you guys to look at all the things we did on that one and see if there's some place where you're just like not really sure why we did what we did. Hopefully it feels familiar this time. Yes, ma'am. Sir. Sorry.
Why is it open circles like on the outside? I understand the middle line, but I don't understand the outside.
You don't understand these are open?
Yeah.
Okay, so if the number comes from the denominator, it's automatically open. So 5, 100% is open. And then because this doesn't have the or equal to bar, they're all open. Any other questions? Okay, let's do 3. It shouldn't take very long, and then we're going to skip down and do 6. And then if there's something you have a question about, I can do more. We have time. I don't want to just keep doing examples if you don't really need them. Okay, this one is slightly tricky. How many numbers do I need to put on the number line? Just one. Just the number 3. You're right. Just the number 3. 2 is never going to be 0. So 2 is always going to be 2. The only thing that matters is what's going to make that x minus 3 0, and it is 3. And then we'll plug in some other numbers. All right, that numerator, is it always going to be something? It's always going to be positive too, so we can just automatically make it a positive. Oh, I didn't ask you this question. Do I do an open or a closed circle at 3? Open. It's open no matter what. It's open because it comes from the denominator, and this already was just greater than. All right, so that's it. Some of these are kind of fast, like that one. All right, and then we're going to skip down and do number 6, too. How many numbers this time? Just one. Just the number one. Why did you guys think 2? Because it's squared? Oh, okay. There are, well, I guess you can think of that like a multiplicity too, but there's only one number we're putting on the number line, and it's the number 1. All right, what about open or closed? Yes. Okay, so my numerator is always going to be 1, so it's always going to be positive. What about the denominator? It's always going to be positive. So what's going to happen here? Exactly. So you can say it like that. That right there, it means an empty set. So if you just want to not write a bunch of things, you can just do that. Or you can say no real solutions. However you want to do it. All right. What questions? Oh, we're not done, but what questions do you have so far? Just one more thing we have to do. It's pretty quick though. Okay, so this is another function, but it's in graphical form, but we can still do the inequalities. So we talked about this. This is a horizontal asymptote. We haven't talked about these. Any guesses on what they're called? Vertical asymptotes. So next lesson we're going to talk about them, but I want you to know something about them. You're never going to get there. The function is undefined at vertical asymptote, so you kind of need to know that to do these inequalities. All right, so on A, we want to know where this function is greater than, no, less than or equal to 0. So I'm going to highlight it. That's going to mean it's underneath the x-axis. And then I'm just going to represent those inequalities. So what's going to happen is this graph is going to get closer and closer and closer to 3, but never quite get there. So that's going to be the starting point of our inequality. We're going to start at -3. It's not going to get there, so we're going to do parentheses. All right, and then it's going to be underneath until we get to -1. So do you think we do a bracket or parenthesis on -1? Bracket. Why did you guys say bracket? Because they're or equal to. It's equal to 0 there. All right, and then we're going to do u. We have a little break where it bumps up above the axis, but then at 2, we start moving below again, and we're going to be below until we get almost to 3. On B is basically just the opposite of what we did. We want greater than 0. So we have this whole section here. We have this tiny part here. And this whole section there. All right, so as we keep going to the left forever, we're going to stay above the x-axis. It's actually going to stay above 1. So that's going to start at -infinity until we get almost to 3. All right, and then we have this little section between -1 and 2. And then 3 to infinity. Yes? Yes, thank you. All right, any other questions? Okay, and then C, we want to know when this function is greater than or equal to 1. Now, when you're doing the algebraic inequalities like these, it has to be a 0. You can't make it be any other number. It won't work. I mean, it would be really hard to make it work. But on the graph, it's fine. So out of what I just had, I have highlighted, what do I need to mark out? Yeah, this little section right here. All the other places is where the function is above 1. It's not actually going to ever get to 1, so that or equal to doesn't even matter on this one. And so what I would do is just take this part out, and that's going to be your answers.